So initially, when I actually looked at this equation, I think I probably did it the way most of you did it. And the very quick engineering approach, V1 equals 0, V2 equals the actual area of the sphere, of the balloon, and without looking at what is the system. So I assumed the actual system was the balloon, as most of you may have. But in this case, actually, the system is the universe. Right? Because the balloon is expanding and doing work on the universe around it. So a slightly bigger system than most of us are used to. So if the work is by the balloon on the surroundings, and we're describing the actual atmosphere in this case. Now, if you've done it through the approach I just described, you will get the right answer, but then you're missing the conceptual principles. So the absolute volume change in this case is the V2 over V1 of the pressure of the atmosphere over the change in volume of the atmosphere. So you're expanding into the atmosphere. I'll let you. So this is the proof. The change in the pressure of the atmosphere multiplied by volume of the atmosphere. Don't worry, it's not that bad if you go through it. Equals the initial pressure of the atmosphere. So times the initial volume of the atmosphere. And the reason you do this is to prove that the change in your system, which is your atmosphere, is infinitesimal. Because you imagine you're just blowing up a tiny balloon compared to the universe. But you need to prove this to say it's isobaric and isothermal, so we can calculate your final volume work. So if you go through this, the pressure of the atmosphere equals the initial pressure times the initial volume over the actual volume of the atmosphere, so the whole universe, or rather the whole world. The change in pressure of the atmosphere equals pressure of the atmosphere minus the initial pressure. And the initial pressure atmosphere equals the initial volume over the final volume minus the initial pressure of the atmosphere. So remember atmospheric pressure, 101, 325. How much are you going to change that if you blow up a balloon in it? So the change is infinitesimal. Yeah. And this is just a mathematical proof. And the initial pressure of the atmosphere multiplied by the initial volume minus the entire volume of the atmosphere over the volume of the atmosphere is the ratio of pressure change. And the pressure initially, so the new pressure of the atmosphere equals the initial pressure of the atmosphere multiplied by the change in volume of the whole atmosphere over the actual volume of the atmosphere, so the whole world. Yeah. So it's just a mathematical proof for that. Yeah. And if you're wondering why, physicists. So the relative volume change is very small compared to the universe, right? Yeah, that's the proof. You can actually put numbers in it if you wish to prove it yourself. Hence, the absolute pressure change will be almost zero. And thus, we can assume isobaric, so there's no change in pressure. That's the first step, because you need to know these before you can drive your volume work equation. Now, conceptually, you probably just went straight to it because it makes sense as an engineering point of view. So, in your career, that's how you would do it normally. This is the principle. This is thermodynamics. You're not chemical engineers here. So let's see if the process is isothermal as well. Same approach. Since the change in internal energy equals Q plus volume work, and you assume there is no heat transfer from the system. So again, humongous system, your balloon will have almost the same temperature as expanding. Right? That's why there is no heat transfer. It's tiny compared to the whole world. So your change in internal energy equals just the volume work. Yeah. Again, first law. So it's an isobaric change, and it's isobaric change in volume of the atmosphere. Remember. So volume work equals minus P dV, or change in volume. Remember CV, your volume work heat capacity, equals the change in internal energy over the change in temperature. And hence, your change in internal energy equals the change in the U, which is your internal energy, multiplied by this, your T2 minus U minus the T1. And if you plug your previous equation, so CV dt equals du into that equation, and you integrate with respect to T2 over T1, your change in temperature, which is again infinitesimal, you'll get mCV dt, so Cm delta T from physics, and you know that mass equals density times volume. Right? So you have your volume of the sphere, you have your density of the air. Using the first law, we can obtain the change in internal energy equals volume work, and rho VCV dt, so your Cm delta T, equals negative P delta V. And your change in the change in temperature equals minus P over the change in the density multiplied by CV multiplied by the change in volume over volume, and the total volume of the universe. So unsubscripted parts of the equation are the universe. Really large numbers. Hence, the temperature change depends only on the relative volume change, and will therefore be nearly zero. So the volume of the universe is infinitesimally changed. Yeah. Physics land. And hence, you can drive your equation. You know that minus P change in volume. You know the change in volume of the atmosphere, which is your balloon, 4 over 3 pi r cubed, volume of the sphere, multiplied by your initial pressure, and you get your change in the volume work. Does that make sense conceptually? I know you need to work through the maths part, but conceptually, does that make sense? You can't really change the volume. You can barely change the volume of the universe. It's a huge universe. Can I get hands if it makes sense conceptually? Okay. And I'll get you guys to have some fun looking through the maths again on the video. And if you have questions, show me your working, just email it to me, take a picture, or ask me. Yeah?